A silent sky flickers, then refuses to return to sleep. Two distant stars erupt, and their light washes across our neighborhood. A green comet stirs and grows a longer veil. Then our own star brightens at the edge and throws a cloud outward. The sequence feels too neat to be nothing at all. If this is choreography, who set the tempo? If it is coincidence, why does it land with such precision? Stay with me, and we will test what the night is trying to say. The first hint arrives like a whisper that refuses to fade. Reports of distant outbursts ripple through observatories, not the usual flickers, but energetic events that briefly punch above their weight in the background of our galaxy. No one on a sidewalk would notice, yet instruments do, and they add a small exclamation mark to the week. Soon after, something closer and brighter changes. A comet that had been following a slow and faithful rise suddenly throws off restraint. Its halo thickens, its tail extends by a noticeable span, and photographs from patient watchers begin to look different from one night to the next. There is no announcement. Only the new shape of the light tells the news. Then, the center of everything responds. On the limb of the sun, a bright region flares, saturating detectors for a heartbeat and pressing a sharp spike into the record. Minutes pass, and the flare becomes part of a larger story. A mass of hot plasma detaches and begins an outward flight, a slow-moving storm that carries magnetic structure like bones inside a cloud. It is not coming for Earth. The angles are kinder than that. It is headed into the crowded plane that the planets share, the same plane the comet is sliding through. The clock on these beats matters. The comet's awakening is followed in short order by the solar event, a separation measured in roughly 2 days by universal time. That proximity does not prove anything. It does not need to. It simply narrows the field of questions to the ones that matter. Are we watching independent systems that happen to fire in sequence? Or is there a hidden connection that rides on geometry and timing, and the way plasma carries information as well as energy? The night sky often hides its choices in ordinary details. A comet can brighten for many reasons. Fresh ices can crack and sublimate. A vein can open on the nucleus. Sunlight can find a path into deeper layers that were cold the week before. A sunspot group can build tension on a rotating face and then let go when the magnetic lines tangle in just the wrong way. Distant eruptions, no matter how brilliant at the source, thin out into a faint drizzle by the time they arrive near us. Every part of that explanation is sober and familiar. It sets a floor under our feet. It also leaves room for a question that refuses to go away. Why this order? Why now? The answer might be simple. In a universe with countless moving parts, alignments will occasionally stack into patterns that look designed, even when no hand has touched them. Statisticians warn that clusters are not rare when the sample is large. That is true and useful, and it defends us against story fever. Yet astronomy is a laboratory as much as a panorama. When nature presents a sequence that looks like a test, the responsible move is not to shrug. It is to define what a real signal would look like, and then to watch with unblinking discipline. So, we begin to frame the experiment. The comet has changed in ways that cameras can catch, its tail and coma now more sensitive to the gusts and waves that run through the solar wind. The sun has launched a structure that will travel for days through the same lanes the comet inhabits. If a shock front sweeps through the tail, we should see the tail bend, thin, sever, or brighten, depending on the direction of fields and the speed of the flow. If nothing unusual happens, that is an answer too. The point is not to force meaning, it is to let the sky decide. There is another layer to the tension. A third traveler, a visitor from beyond our system, is slipping through the inner lanes as the month turns. It hides in glare for Earth-based eyes, but does not hide from the calendar. Its presence thickens the atmosphere of the story without demanding a conclusion. For now, it stands like a shadow at the edge of a stage, waiting for its cue. The comet is our visible lead, the sun is our source of energy, and timing is the fragile line between awe and assumption. Listen to the tone of the week. Instruments hum and then fall quiet. Images stack and reveal texture in the comet that was not there a few nights back. Solar monitors pulse with normal activity and occasional spikes, the kind that demand a second look but not a headline. We are not promised a spectacle. We are promised a chance. That is enough. When the pieces line up, you do not declare victory. You sharpen the plan, you mark the nights, you invite people with clear skies and steady hands to stand outside and hold still. The paradox at the heart of this story is simple. A tiny nudge at the right time can do more than a shove at the wrong time. Complex systems behave like that. They reach a point where small inputs can determine when a change happens, even if they do not decide whether it will happen. If the comet is about to meet a wave, the night will show it. If not, the beauty of an ordinary tale under a new moon will do its quiet work, and the lesson will be patience. Either way, the test has begun. The first page has turned. We now set the timeline that will guide the rest of our journey, and we place each event on the clock to see whether the pattern tightens or dissolves in the light. We spread the week across a clean line, and the story sharpens. First come the reports that distant stars have erupted. Their light is a courier that travels without delay, so the first notices arrive almost as soon as instruments can recognize the change. The entries in professional logs read like cool notes, but the effect is hot. A background that should be steady now hums. Hours turn, and the next mark appears. The comet brightens more than a calm curve would predict. It is not a theatrical leap, but it is quick and clear enough that observers in dark places see a change with ordinary optics. The photographs confirm it. Then the sun writes its line. A flare lights the limb, and a cloud of plasma takes flight, a bubble that will cross the inner lanes in days rather than hours. The list is simple. Eruptions far away. A comet wakes. A star reacts. All within a narrow window. Now the hard part begins. We summon a question that feels colder than the images. Are we stacking isolated events because the human brain loves a story? Pattern seeking is a survival trait, and also a trap. Our eyes group stars into figures that never existed. Our minds can thread meaning through any cluster, if the cluster is dramatic enough. We need a way to resist this warm impulse without throwing away the chance to learn. So we put rules on the table. Order matters, proximity matters, mechanism matters most of all. If we cannot sketch even a possible path by which one event could influence the next, then the sequence is poetry, and nothing more. Order is plain. Proximity is real but not proof. Mechanism is the cliff that separates wonder from result. Light from distant eruptions can reach us quickly, yet the energy that arrives is thin compared to sunlight. A comet can jump in brightness when new veins of volatile material open. A sunspot group can flare because its own tangled fields cross a threshold. The pieces can move without touching at all. The challenge is to identify what a touch would look like if it were there, and to admit that a clean absence is just as valuable. We lay times on a universal clock. The comet's surge begins. Roughly 2 days later, the solar flare and the outbound cloud are logged. The difference is short enough to invite questions and long enough to allow. Travel only if the signal is not a particle storm, but something more abstract. That line of thought is speculation until we place it next to data. We mark how long a shock typically needs to reach the inner orbits. We mark when any known shock from this flare would intersect the region of space the comet is moving through. We plan to compare those marks with whatever photographs and radio logs amateurs and professionals collect. This is the discipline that keeps a mystery from drifting into myth. The timeline is not only about the order of events, it is a way to set traps for coincidence. If changes in the comet track the arrival of a shock that can be mapped, and if similar alignments repeat across many cases, then the story becomes heavier. If nothing lines up, the story becomes lighter. Either way, the clock frees us from pure impression. That is the quiet power of sequence. It lets you test a claim without a debate about taste. There is another practical reason to care about timing. The sky is about to offer a new moon, and the comet will be near its closest approach to Earth. Photographers will have better contrast. Small telescopes will drink more detail from the dark. The window is short, but a short window concentrates attention. A week can feel like a stage if the cues are sharp. That stage is why we set the timeline at all. It tells us when to point lenses and when to expect nothing. By the end of this exercise, the pattern may look less magical. That is not a defeat. It is a relief. If the night gives us a cut tail or a sudden kink that coincides with a traveling shock, the case grows stronger. If it gives us a quiet veil of gas under clean stars, we still win. In both outcomes, the clock does its job. It keeps our attention honest. The line is drawn. Events sit in place. In the next beat, we stop staring at the calendar and go back to the comet itself. We look at its changing face and ask what could wake it so quickly and what that awakening means for the days ahead. The comet had been a polite guest in the sky. It brightened a little each night, followed a curve that felt obedient, and kept a modest tail that most people would miss without guidance. Then the pattern broke. In the span of a morning, the coma looked denser, like breath that has turned to frost in colder air. The tail extended by a noticeable slice of the sky, not a dramatic banner, but enough that careful observers felt a thrum of surprise. Photographs taken hours apart did not match as they usually do. The edges of the coma showed texture that had been smooth, and the tail carried faint ribs that hinted at forces moving within it. What flips a comet from calm to lively is not magic. Sunlight digs into the nucleus and finds new pockets of volatile material. When a crack opens, gases escape, dragging dust with them, and the whole cloud around the nucleus grows. The brightness we see is the sum of light scattered by countless grains and molecules, so a small change in supply can feel large to the eye. Sometimes the heat reaches deeper layers that had slept for ages, and the release is sharper. That is why comets have moods. They carry fragile plumbing that no one can map from Earth, and when a valve opens, the sky takes notice. The change is more than a glow. A comet lives inside the solar wind, a river of charged particles that flows outward from the sunday. When gas leaks from the nucleus, ultraviolet light and collisions can strip electrons and turn neutral particles into ions. Those ions feel the magnetic field that threads the wind, so they align and stream away. The straight bluish tail that often appears in images is a map of that invisible pull. Dust does not follow the same rule. It is heavier and follows a curved path under sunlight, pressure, and inertia. The two tails share a source and then diverge, one ruled by fields, the other by light and motion. This is where the story starts to carry tension. The surge in gas and dust means the wind has more material to push. Plasma physicists call this mass loading. It is a plain phrase for a complicated effect. Add material to a flow, and you can slow it or bend it. You can set up waves and boundaries that were not there the hour before. In a quiet wind, the comet's ion tail can stretch in a simple line. In a busy wind, the tail can twist or even disconnect as field lines change and reconnect. The images from history show tails that snap and regrow in less than a day. The sight is eerie. One moment, the comet looks regal. The next, it looks clipped. Then it grows a new train, like a lizard regrowing a tail. The fresh texture in the coma hints that the comet has entered a more sensitive state. Dusty plasma behaves in ways that feel disobedient to simple rules. Grains can charge and discharge. They can cluster. They can create small electric fields that steer ions and electrons nearby. None of this turns the comet into a generator that can move the sunday. That scale belongs to stars. It does mean that the envelope around the nucleus can act like a living boundary. It can accept or resist the wind in ways that shift from hour to hour. For a watcher at a small telescope, the effect is subtle. A faint jet blooms on one edge. The inner coma looks lopsided for a night. The tail slides a few degrees away from yesterday's line. There is also the matter of distance. The comet is closer to Earth now than it was at perihelion. That means the same physical change pays a larger dividend in apparent size. A tail that grew slowly a week ago now seems to leap. The sky will also go darker around the new moon. So the comet enjoys two gifts at once: more output from within, and better contrast from without. It is a perfect recipe for a public show if the wind decides to add drama. We remember that the recent flare and the outbound cloud exist whether or not they ever meet this object. They travel through a system full of structure. The region near the plane of the planets is not an empty flat. It is a stack of ripples where the magnetic field changes its mind and where slow and fast streams of wind collide. A bright comet is both a beacon and a probe in that sea. If a shock front arrives, the ion tail can act like a windsock that flips when the breeze shifts. If no shock arrives, the tail can still grow and thin with the daily rhythm of heating and rotation on the nucleus. Our task is not to bless every shimmer of the tail as a sign, it is to record and compare. We will ask whether a kink appears when a known disturbance passes a calculated point. We will ask whether the changes repeat at intervals that match the beat of the rotating Sunday. We will remember that noise is a kind of answer when you seek a faint signal. The excitement comes from the possibility that this surge has turned the comet into a more responsive instrument. It is ready to write the wind for us in pale blue ink. In the next part, we turn our face back to the star. We ask what its eruption means for the space the comet must cross, and how a slow storm of plasma can sculpt a tail that is already awake and alert. The sun does not announce its moods to anyone. It rolls in silence and then, without warning that lay people can feel, a bright knot on its limb blooms, X-ray monitors spike, ultraviolet loops swell and snap. In white light, the event would pass unnoticed to most eyes, yet instruments record a sharp burst that qualifies as a strong flare. The light is only the first act. Minutes to hours later, a greater thing steps off the surface and begins to move. A coronal mass ejection forms, a swollen bubble of magnetized plasma that drifts and then accelerates into interplanetary space. It is the kind of structure that gives the solar wind bones and teeth. Direction is everything in this game. The ejection does not aim for Earth. It rises from a region that places its path along the crowded plane where most planets travel. That same plane is where our comet threads its way night after night. The thought alone raises the pulse. If the expanding cloud and its shock skirt the lanes the comet must cross, the encounter could become a lesson written in the shape of a tale. But the word "if" must be respected. These are three-dimensional paths through a moving sea, and small angular differences turn dramatic hopes into quiet misses. Imagine the bubble as a storm moving across an ocean that is already flowing. The solar wind is not a static background. It streams, curls, and spirals with rotation, so the ejection rides a conveyor that twists like water from a spinning sprinkler. The magnetic field lines that cradle the cloud reach outward in a long spiral. They will not carry the plasma in a straight line, but in a graceful arc. That arc will sweep through longitudes that sometimes match the comet's position and sometimes pass harmlessly wide. Predicting the match requires models and patience. Watching for it requires cameras and luck. If a meeting happens, the physics is as beautiful as it is harsh. A comet's ion tail is made of particles that listen to magnetic fields. When a strong shock arrives, the field direction can flip relative to the tail in a blink. Reconnection can follow. Field lines that had tied the tail to the wind can break and stitch themselves elsewhere. The result in images looks like a severing. The graceful line thins, forms a gap, and then regrows as fresh ions stream away from the nucleus. Other times, ram pressure alone does the work. The fast cloud rams the slower flow that had been carrying the tail, and the structure shreds like smoke in a gust. None of this implies that the comet caused the sun to erupt. That would be like asking a leaf to push a storm into being. The energy scale difference is beyond stark. The star holds nearly all the mass in the system and stores the magnetic power that drives such events. Yet timing still earns respect. Complex systems can reach thresholds where small nudges decide when a change arrives. That is different from deciding whether a change arrives at all. Some researchers keep this door open in their minds, not as a claim, but as a caution that timing in nature is not always polite to our intuitions. There is also the matter of travel time. A large ejection often crosses the orbit of Earth in a few days. A small or slow event can take longer. The comet lies closer to the Sun than Earth does, so a shock could reach it sooner than it would reach us. That means observers on Earth may see a tail react before magnetometers on the ground register the broader passage. A response in the tail would then become an early signpost for conditions that might later touch our planet in a softer form. Tails have served this role before. They are fragile, large, and responsive. They are nature's streamers. The flare itself is not the main actor once the cloud is moving. A flare is a flash of light and a record in a detector. The mass ejection is the weather. It carries density, speed, and field orientation. It is the difference between a bright lightning stroke and the wind that bends trees. Coronagraphs watch that wind form and expand. Observers measure the halo size and the direction of greatest brightness. From those cues, they infer the likely path. None of these inferences are perfect. They do not need to be. They are good enough to set expectations for the nights ahead. As this ejection departs, the star rotates and exposes new regions. The surface is busy this season. More bright knots parade across the disk than modest forecasts suggested a few years ago. That background activity means our comet swims in a sea that is both rich and restless. The odds of a chance encounter with a shock are not high on any given day, but they are not negligible across a week when the sky is dark and the comet is near. The tail will tell us which it is. It will either hold steady like a ribbon in a gentle breeze, or it will quiver and break, then stitch itself anew. We have the moving parts on the table: a comet that just woke, a star that just threw a stone into its own river, a lane in space where both paths might cross. To see whether crossing becomes contact, we need to understand the shape of that lane and the strange sheet that ripples through it. That is where we go next, into the geometry that does not sit still, and the map that makes or breaks the meeting. Space is not an empty hallway. It is a braided river where currents part and rejoin, where invisible banks steer the flow. When we speak of the ecliptic, we mean the wide road where most worlds travel. It looks like a flat disk in diagrams, yet in practice it is a humming corridor shaped by rotation, by magnetic fields, and by the rhythm of the solar wind. Our comet keeps to this road. The outbound cloud from the sun spreads into it. The hidden visitor from beyond also glides very near that same broad lane. The word coincidence hangs in the air like fog. Geometry can inflate a coincidence until it feels like intent. The first truth is simple. Planets, and most comets, share roughly the same plane because they were born from the same spinning sheet of gas and dust. The solar wind inherits that rotation. It drapes field lines into spirals that lie close to this plane. The second truth is more subtle. The magnetic environment near this road is not smooth. It carries folds where polarity flips. It carries junctions where slow and fast streams meet and create compression. It carries scars from older ejections that still drift like weather fronts after the thunder has passed. A bright comet that travels through this weather becomes a tracer. It reveals the shape of the river even if we cannot touch the water. If we draw the scene in 3 dimensions, we see an orchestra of alignments that do not require design to be striking. The comet moves along a curve that brings it near Earth, while the moon fades to darkness. The visitor from outside drops toward its closest pass inside the orbit of Mars, but keeps its apparent position close to the glare of the sun from our point of view. The ejected cloud balloons into the plane and rotates with the background flow. None of these paths guarantee an encounter. All of them increase the chance that our cameras and radios will be pointed in the right place at the right time if something unfolds. This is why geometry can raise stakes without claiming more than it should. If a shock wave crosses the ecliptic near the longitudes where the comet is traveling, it will sweep through a structure that is already awake from a fresh outgassing. If the hidden visitor swells a faint envelope as it heats, that envelope will share the same road and feel the same gusts. Geometry cannot force a cause. It can only make the stage smaller and the actors louder. There is a further complication that works in our favor. From Earth, we see the snake-like sheet, where the magnetic field changes, sign nearly edge-on. Visualize a ballerina skirt that ripples outward from the sundae. Each ripple is a fold where the field flips. Objects that cut through those folds can experience sudden changes in the way their ions are steered. The ion tail points roughly along the magnetic flow that carries it. When that flow turns across a fold, the tail can pivot or break. The timing of such turns depends on the exact shape of the skirt and on how the wind has been sculpted by the latest storms. The calendar helps the observer, even as it teases the analyst. New moon nights reduce glare. The comet's closest approach enlarges every feature. A tail kink that would be subtle a week earlier can become obvious. Small telescopes gain reach. Long exposure cameras gather structure that looks like feathered lines and soft ribs within the coma. These traits tell us about geometry, more than about raw power. They are signs that the tail is a windsock rather than a torch, and that its aim is set by space weather as much as by sunlight. None of this makes the story more certain. It makes the experiment more focused. We do not look everywhere and see meaning. We look along a known lane and wait for a known kind of interaction. The geometry tells us where the dice are rolling. The outcome remains a roll. That is the honest position. It keeps us from reading purpose into orbits that are only doing what orbits do. So, the map is drawn. The comet is a tracer in the stream. The visitor is a shadow crossing the bright coin of the Sunday. The cloud from the flare is a slow-moving front that may or may not sweep the lane in time. In the next part, we step inside the sheet itself, the place where the field flips, to understand why it matters so much for tails, for comas, and for anyone trying to read a message in the motion of light. Imagine the sun wearing a skirt made of charged mist. It ripples as the star turns. It lifts and sinks in slow motion. It folds into pleats that sweep past every orbit we know. This is a picture of the heliospheric current sheet, the grand surface where the magnetic field of the sun changes sign. It is not a flat wall. It is a living membrane that spirals outward with rotation, and it is wide enough to wrap the inner system like a gauze. The comet we watch is not just flying through sunlight. It is moving through this membrane, crossing and recrossing the folds, as if stepping across the edges of a vast spinning fan. The central mystery of this sheet is simple to state. What happens when a cloud of newborn ions meets a boundary where the field flips? The ions have been torn from neutral gas by ultraviolet light. They are guided by magnetic lines in the wind. As those lines sweep through the folds, the direction of the guiding force can change. The tail then becomes a sensitive needle. It points one way, then another, with a poise that reflects the pattern of the sheet. A gentle fold makes a gentle turn. A sharp fold can make a kink. A shock riding the sheet can make a break. If you could float above the sun and look down, you would see the sheet as a spiral that resembles a slow water wave curling on a shallow beach. The wave crest is the place where the polarity flips. Planets and comets do not sit on a single crest. They weave through rising and falling sections as they orbit. Each crossing is a chance for a tail to pivot. Each crossing is a chance for a coma to reshape. This is not folklore. Probes that tasted the solar wind near Earth have watched the magnetic sign switch as the spiral turns. The rhythm is not steady. Solar activity sets the tempo. A quiet star keeps the sheet smooth. A restless star fills it with wrinkles. For the comet, the sheet is both a stage and a script. When fresh gas pours into the wind, the cloud around the nucleus becomes more conductive. Small electric fields can appear within that dusty plasma. They lift fine grains and steer ions with a bias that depends on the field they encounter. The new moon nights help us see these small effects. The sky is darker. The apparent size of the coma is larger because the comet is nearer. A small jet stands out as a bright hairline streamer. A minor tilt in the tail shows as a distinct bend. None of these are random. They trace structures in space that cannot be seen directly. The sheet also carries traffic. Shocks from flares and eruptions ride along it because the field lines that define the sheet guide them. The shock is like a pressure wave that sweeps dust from a table. If the comet happens to sit on a part of the sheet that the shock visits, the tail can display the classic signs. You can watch a cut form and travel down the tail away from the nucleus. You can watch the detached piece drift and fade while the nucleus grows a new streamer. There is no pain in this process for the comet. It is a rehearsal the sky has performed many times across many apparitions. It is still startling every time because it reveals the invisible with a gesture that any eye can read. Geometry determines how many folds the comet meets in a week. The ecliptic plane is a guide, but not a promise. The sheet can warp above and below that plane like a ribbon on a breeze. The number of crossings depends on where the lobes of the spiral sit during that rotation. Forecasts exist in broad strokes, yet the exact shape at any hour is a product of recent eruptions and of older structures that have not yet washed away. This is why patience is essential. A single night offers a hint. Several nights reveal a pattern that speaks with more authority. There is caution to keep in mind. A tail can change because the nucleus turns and opens a new jet. A tail can shift because the viewing angle changes as Earth moves. These are ordinary causes that do not require a sheet or a shock. The task is to compare the timing of changes with the expected arrival of folds and waves. If they match often and cleanly, confidence grows. If they do not, then the comet is writing a different story, one governed by its own plumbing and by the simplest play between sunlight and dust. We now have a map that includes more than orbits. It includes a surface that breathes. It includes lanes where disturbances travel. Into this living geometry, our comet has poured fresh material, making itself an excellent antenna. The next question is what the dust and charged grains inside that antenna can do to the script. We turn to the strange behavior of dusty plasma, the spark and the whisper that dust can add to a flow that otherwise would pass without drama. Comet light looks soft to the eye, but the physics inside the glow is sharp. What makes this comet interesting now is not only brighter gas, it is dust, and dust changes the rules. When sunlight shakes loose grains from the nucleus, those grains step into a storm of radiation and charged particles. Some grains pick up electrons and become negatively charged. Others lose electrons and tilt the other way. The result is not a tidy gas cloud. It is a dusty plasma, and dusty plasma can misbehave in ways that pure plasma does not. It can clump, ripple, and build small electric fields that steer the surrounding flow. That is why a mild surge in outgassing can have outsized effects on shape and texture. Think of the coma as a town square where everyone started neutral at dawn. Midday arrives and a wind blows through. People raise umbrellas. Some umbrellas catch static, others repel it. Crowds form where there were none. A path opens where there was only noise. In the comet, grains are the crowds. Fields are the paths. The scene reorganizes itself, even if the wind has not changed much. Photographs record this as a change in the inner glow. Edges that looked smooth become feathered. Jets that looked steady develop beads along their length. The human eye reads these patterns as beauty. The physicist reads them as a boundary learning new tricks. Mass loading is the next piece. When the comet empties more gas into the wind, it does not only light up, it adds matter to a flow that was thinner the day before. The solar wind must carry that new cargo. The flow can slow or reshape. Magnetic lines that weave through the wind can bend around the denser pocket that the comet has created. Where the bend is sharp, small shocks can form. Where the bend is gentle, waves can roll. In both cases, the tail becomes a write-out of the change. It can sway, narrow, or flare. It can even break if the local field geometry flips quickly and reconnection cuts the tether that ties ions to their old route. Dust complicates all of this, because grains do not simply follow the field. They feel sunlight pressure, they carry inertia, they exchange charge with the gas that rushes by. A large grain may drift like a pebble tossed into a stream, hardly perturbed by eddies that would spin a leaf. A tiny grain can charge and discharge in moments, and can be swept into sheets or braids that image stacks reveal as delicate ribs. The mixture of sizes in a fresh outburst creates a layered structure. Close to the nucleus, the coma can glow with almost even light. A little farther out, the ribs emerge where fine grains and ions cooperate. Farther still, the ion tail draws a ruler straight line, while the dust tail bows under sunlight like a kite in a steady breeze. There is a reason dusty plasma gets attention in laboratories. It can self-organize. Under the right conditions, charged grains set up double layers and small sheaths. These are zones where charge separates and an electric field forms. In space, these microstructures are fragile, yet a comet supplies them constantly. The nucleus turns, new jets light and fade, the solar wind fluctuates, each change refreshes the patterns. You can think of the inner coma as a living screen that redraws itself every few minutes. If a strong external driver arrives, for example the front of a coronal mass ejection, the screen will respond with a sweeping gesture rather than with fine embroidery. That contrast is useful. It lets observers distinguish local plumbing from large-scale weather. Scale still matters. The sun dwarfs the comet in every measure that counts for driving eruptions. Nothing in the dusty cloud will push the star into a new mood, but scale does not erase sensitivity. A ready system can respond to a nudge that would mean nothing on a quiet day. The dusty coma is a ready system. It is charged, structured, and in motion. When a folding sheet passes, or when a shock skims the lane, the comet can amplify that touch into a visible change. The same inputs would do less to a rock with no atmosphere. They would do less to a comet that has not recently awakened. Timing multiplies consequence. For practical watchers, this means simple things. The best clues often hide near the head of the comet, in the inner degree where the coma transitions into a line. A new jet can appear as a wedge with a bright edge. A change in the field can appear as a pivot, where the ion tail meets the coma, a hinge that was not there the night before. Slow evolution points to rotation and plumbing. Abrupt changes hint at space weather. If the shock from the recent solar event reaches the right longitudes at the right hours, the dusty plasma will mark the moment for anyone with patience and a steady tripod. Dust is the fire that carries shape in this story. It turns a simple gas lamp into a living lantern. It writes the wind. It remembers the fold it just crossed and the gust that just passed. In the next beat, we face the question that follows naturally. Are we seeing choreography or noise? Can these patterns rise above accident and claim a place in the ledger of cause and effect? To answer that, we set the standards for evidence, and we walk the thin line between wonder and the rules that keep wonder honest. Every mystery eventually meets a judge, and the judge in this case is the standard of evidence. The past few nights have given us images that feel like whispers of intent, a tail that narrows, then briefly frays, a coma that shows ribs near the core, then smooths, then shows them again. We feel meaning in the rhythm, because humans are tuned to find rhythm everywhere. The task now is to measure the rhythm against a metronome that does not care about our feelings. That metronome is timing, repeatability, and a path that runs from physics to prediction and then back to observation. Begin with timing. If a solar shock leaves the sun, it will need time to cross the lanes where our comet travels. Estimates of that time come from the speed of the ejected cloud and from the background wind. None of these estimates are perfect. They are good enough to draw a window on the calendar. When photographs taken within that window show the specific signatures of stress, a sharp pivot where the ion tail meets the coma, a faint disconnection that drifts away, a sudden brightening along a thin spine, then interest grows. When similar signs occur, outside the window, interest cools. The difference is not dramatic. It is the slow confidence that builds when a pattern lines up more often than it misses. Repeatability comes next. One night can deceive. Edges sharpen and soften with focus and seeing. A camera angle can change. The nucleus can rotate and uncover a fresher jet. None of that can be called coupling. 3 nights in a row, each with the same context, each with the same trend in the tail and coma, begins to deserve attention. 5 nights, where the sequence matches the march of a mapped disturbance across the sheet, becomes stronger. If the same sequence turns up again months later, with a different comet and a different shock, the case is stronger still. This is how fragile ideas survive contact with the real sky. They learn to breathe on their own. Finally, there is the mechanism. We do not need a full blueprint to move forward. We do need a corridor that a signal could plausibly walk through. The corridor here runs through the ion tail and the sheet. A shock steepens the field and the flow. The field turns abruptly. The ions that form the tail must follow that turn. When the turn is too sharp, the tether breaks and reconnects elsewhere. The visible effect is a cut. When the turn is modest, the effect is a pivot. Dust takes longer to respond, so the dust tail keeps its quieter arc. This difference of response is important. It lets us separate a true space weather touch from a simple change in jet geometry. A jet change will push both tails together like a garden hose moving left. A space weather touch will bias ions first, then dust later, or not at all. Notice how none of this requires a comet to influence the Sunday. The energy flows one way. The wind and the shock arrive from the star and sweep through the object that happens to be in their path. We keep this arrow clear because it protects the story from flights of fancy. A minority view holds that small objects can sometimes alter timing in a sensitive system. It remains uncertain whether this applies here. If it did, the only sign would be a subtle shift in when a flare or a smaller eruption occurred. No such sign is demanded by the data we have. We can test the simpler direction first. and leave the other path for future work, if any. There is also the counterpoint. Many comets live entire apparitions without a theatrical cut. They grow, they fade, they display gentle kinks that come and go with rotation. If our comet does the same through the new moon window, the result is not disappointment, it is clarity. The absence of a strong signature in the right window weighs against coupling. That weight should be reported with the same care as a positive. Boredom can be a beautiful truth in science. It means we have learned something about limits. So which is it? Choreography or noise? The honest answer is that the verdict will not turn on a single night. It will emerge from a stack of images, from logs kept in notebooks, from radio spectra that show or do not show the footprints of a shock at the right hour. The drama comes from waiting with a plan. The integrity comes from keeping the plan when the sky offers silence. If the pattern is real, it will repeat enough to stand. If it is not, the next parts of our journey will still matter. There is another actor in this play. It moves behind the glare, it comes from far away, and it may give us a different way to ask the same question. We turn now to the visitor behind the light, and to the riddle of how an interstellar traveler behaves when it meets a star that does not know its name. Somewhere inside the blaze of daylight, a traveler slips past the curtain where our eyes fail. It does not come from the family of worlds that grew up here. It fell in from the wide dark between stars, and it is now threading the inner lanes like a stranger who knows the map only by instinct. Its path is hyperbolic, which means it is visiting once and then leaving forever. As the month turns, it will reach closest approach to the Sun, a passage just inside the orbit of Mars, close, in cosmic terms, yet still far for any human sense. The simple facts end there. The rest of the story is a set of questions that sharpen as the light grows. What kind of body is it? Is it a dry shard that only glows by reflected sunlight? Or does it hide volatile ices that wake into gas when heated? Early hints suggest a faint envelope may already be building, a soft coma that swells when the surface warms. It remains uncertain whether this envelope will expand into a grand spectacle or stay as a ghost that only careful instruments can confirm. One possibility is that the traveler holds hypervolatile material, ices that sublime, even at distances that would leave ordinary comets quiet. If so, the coma could inflate quickly as the sun turns the temperature dial up a few notches, and the surrounding wind would meet a new pocket of plasma that it must carry around. The geometry complicates every plan. Seen from Earth, the visitor clings to the sun in the sky. Its solar elongation stays small through the approach, which means ground-based telescopes must fight glare and air and daybreak. Yet, geometry also writes a favor into the script. Spacecraft near Mars will enjoy a cleaner angle as the object sweeps by on the inside lane. That vantage will not last long. The interval is measured in days. Still, it may allow spectra and dust counts that reveal composition and activity with a clarity that Earth cannot match during conjunction. If the coma contains carbon monoxide or other fast-acting gases, the signatures may show. If dust size distribution differs from native comets, the light curve may tell a different story. There is a poetic question at the edge of all this. Do interstellar objects carry the electrical memory of the places they came from? A competing view suggests there is no memory to carry, only material that behaves like any other, under sunlight, and wind. Evidence is limited, but one inference is that an object forged in a different stellar nursery might present an unusual mix of grains and volatiles. That would not change the rules of physics. It could change the way those rules draw patterns in the envelope. A dusty plasma, born from an unfamiliar recipe, can set up microfields and waves that look slightly off from the norms we have learned to expect. The differences would be subtle. They may appear as odd jets, as shallow brightening that rises and falls with a rhythm that does not match common rotation rates, or as faint radio signatures that hint at a less familiar chemistry. The traveler also offers a test of non-gravitational behavior. Active comets push themselves with the recoil of gas jets. That recoil can show up as tiny anomalies in the track across the sky. In a quiet object, the path stays close to the one that gravity alone would dictate. In an active one, the fit improves if you allow a small push that grows as the sun heats the surface. If our visitor shows such a push, the case for significant outgassing strengthens. If it does not, the object leans closer to the dry shard idea, a body that passes near the sun with little more than a glitter. Both outcomes are interesting. Activity gives us a living envelope to read. Inactivity gives us a clean test of how interstellar rocks endure near a star. Speculation thrives near the limits of sight. We keep it on a leash by naming what would count. A clear coma that grows as perihelion nears, hints of a straight ion tail that tracks the local field, rather than the curved sweep that dust prefers. Gentle color shifts that point to exotic ices or to very fine grains. These are the signs that would move the traveler from rumor to presence. There is also the mirror set of signs that would quiet the hype. A point source that brightens and fades like a simple sun-warmed rock. A track with no measurable recoil. A light curve that flows like a reflected glint, rather than like gas. There is a temptation to fold this stranger into the ongoing puzzle of the comet and the recent solar ejection. Resist it for a moment. The honest frame is simpler. The visitor gives us a second probe in the same restless sea. If it grows a coma, it will feel the sheet that ripples through the plane of the planets. If a shock crosses that lane, the visitor may show a brief hint of stress, even if Earth cannot see it clearly. If it stays quiet, the contrast with the bright native comet will be just as useful. Two bodies, one perhaps lively and one perhaps reserved, moving through the same environment at the same season. That is a controlled comparison that nature rarely offers. The spectacle is not guaranteed. The mystery is, behind the light, a traveler approaches a star that has never warmed it before. It will round the bend, it will either whisper or sing, and it will go. Our job is to listen with whatever ears we can borrow. Mars can help for a short while. Earth can help in the weeks after, when glare eases and the path becomes cleaner. Before we turn to the red planet and its front row seat, keep one last image in mind. A small ghost near the sun, a faint plume that may be nothing at all, or maybe the first breath of an interstellar object meeting our wind for the first and last time. Mars sits in the quiet light like a copper coin, and for a brief spell, it holds the best seat in the house. While Earth stares into glare, orbiters around the red world trace smooth arcs with steady instruments and clear lines of sight. The interstellar traveler passes inside the Martian orbit, on a course that is close enough to tempt, yet far enough to be safe. This geometry gives Mars a privilege that Earth lacks right now. It can watch the visitor against a darker sky, and it can study the faint breath that may be rising from its surface as the sun turns up the heat. What can Mars see that we cannot? It can witness the early stages of a coma, if one exists. Spectra, taken with a calm baseline, can reveal simple gases that make up the first whisper of activity. Carbon monoxide, carbon dioxide, perhaps a hint of water or nitrogen species if the object carries such stock. The exact mix remains an open question. A competing view suggests that the traveler could be nearly inert, a shard with little to give, and that any spectral features will be thin to the point of doubt. Evidence is limited, but one inference is that an interstellar body can hold exotic ices that simmer at distances where ordinary comets stay quiet. If those ices are present, Mars has the angle to catch them first. Mars can also time the light. A growing coma does not brighten like a mirror. It swells with a rhythm set by heat and by the opening of vents. The light curve can reveal rotation, or at least the presence of jets that rise and fall as the body turns. If the surface holds a few dominant sources, the curve will show steps or soft pulses. If activity is diffuse, the curve will smooth out and climb with a slow patience. Either way, early timing helps. Once the object passes perihelion and the geometry changes, it will be harder to separate the engine from the glare. There is a third advantage. The Martian upper atmosphere is sensitive to dust and ions. We have seen what a rich coma can do to it during a past encounter when a long-period visitor crossed near and filled the thin sky with metal ions and fine grains. The interstellar object will not pass nearly as close, so the spectacle will be muted. Still, any measurable rise in metallic ions, any transient glow in the ionosphere, any brief change in distribution at high altitudes would mark the visitor as an active player. These would be delicate signatures, small bumps rather than dramatic spikes, A quiet change is still a voice when the background is as still as Mars usually is. All of this depends on coordination and on luck. The window is short, days, not weeks. Orbits cannot be changed at a whim. Shadows from Mars itself can block a line of sight at the worst moment. Dust in the Martian air can veil the limb and hide a faint plume just when it becomes interesting. These are not reasons to doubt. They are reasons to be careful about claims. A clean detection would be a gift. A non-detection would be a useful constraint. In either case, the vantage will add weight to our picture of the traveler, and it will do so before the glare eases for Earth. There is also a narrative advantage. Mars gives us a way to compare two worlds, reacting to the same season of the Sunday. The bright native comet moves through the inner lanes and responds loudly to heating. The interstellar visitor moves through nearby lanes and may respond quietly or not at all. If both objects feel the folds of the current sheet, we can look for shared rhythms and for solitary notes. A shared rhythm would hint at environmental control. A solitary note would argue for internal plumbing as the main artist. This is the kind of comparative scene that turns a set of pictures into a lesson. For viewers at home, this part of the story happens off-stage. You will not see the visitor beside Mars with your own eyes. You will see the result in the way the next parts of the arc address what is known and what is not. If we hear that faint gases are present, the stakes rise for later encounters with the wind. If we hear that the object is quiet, the stakes shift toward a purer test of geometry without the noise of jets. Both answers are good answers. Both will guide how we read the sky when Earth finally gets a clearer look. The curtain is about to lift on the week that matters most for the comet. The new moon waits. The lanes have been drawn. The shock from the recent solar event is in transit, if it was strong enough to persist. The traveler from the dark slides toward its warmest moment. Mars has spoken, or it soon will. Now we turn back toward Earth, and to the nights when anyone with patience can watch the test unfold in the cleanest dark the month can offer. The calendar finally becomes a character. A narrow span of nights gathers all the advantages we asked for, and it hands them to anyone willing to stand in the dark and wait. The moon thins to nothing, and then disappears. The comet slides to one of its closer points to Earth. The air grows cleaner in the cool of late night. This is the window. It is not long. It does not care about plans. It rewards preparation, patience, and a small tolerance for cold hands. If something is going to happen, this is when the sky is most willing to show it. Darkness is a tool. Under a new moon, a faint tail steps out from the background and becomes a line with character. The coma stops looking like a fuzz and begins to show grain and texture. A careful eye can see the inner light bloom and fade with the slow rhythm of the nucleus as it turns. A camera on a sturdy tripod can go further. It can gather minutes of starlight without a trail if the lens is short and the aim is steady. Then the ribbing in the coma appears. Then the ion tail settles into a thin, straight thread, while the dust tail bows. These are the details that write the weather of space for anyone who will read. The schedule for this window is simple in spirit and precise in practice. Look for the comet in the hours after twilight ends or before dawn begins, depending on position and date. Let your eyes adjust. Protect them from white phone screens. If you have binoculars, sweep slowly. A greenish haze can give the comet away. If you have a camera, start with short exposures to find the field, then lengthen by a few seconds at a time until stars just begin to smudge. If the sky stays still, take a short sequence so that small changes do not hide in a single frame. Timestamps matter. A note of the minute and the location matters. Humble data become powerful when the network grows. What should you hope to see? Hope for a kink near the head of the comet. Hope for a shift in the direction of the thin tail that looks sharper and bluer than the dust. Hope for a cut that appears as a darker lane between the nucleus and a piece of tail that drifts away like a ghost. None of these require perfect optics. They require contrast and context. They are more likely to appear if a shock has arrived from the recent solar event and if it still has strength when it crosses the comet's lane. They are also more likely when the comet has been lively in the days before. A sleepy nucleus writes a quiet diary. A wakeful one writes with flourish. There is a second voice to listen for. Radios tuned to the right bands can hear the sun when it throws tantrums. A Type 2 radio burst sounds like a slow slide in frequency, as a shock walks outward through less dense regions. A Type 3 looks like a fast streak as electrons race down field lines. You do not need to become a radio astronomer to benefit from this. Many groups publish logs or live plots. If a burst occurs during the window, and if images show changes near the comet on a similar clock, interest grows. If the sky is quiet on both fronts, the mood cools to a clear and useful calm. Caution sits beside excitement in this window. Not every change is a message from the Sunday. A coma can grow because a jet turned into view. A tail can shift because of perspective. Thin clouds can fake structure. Artifacts can hide in aggressive image processing. This is why the window works best when many eyes watch. Your frame can confirm a neighbor's hint. A second location can rule out a trick of weather. A third can show that a feature moved with the tail rather than with the foreground air. The map of watchers becomes as important as the map of magnetic folds. The beauty of this moment is that it asks little and gives much. You do not need to travel. You need a clear horizon, a quiet place, and a few minutes of stillness. The comet will be modest by the measure of famous apparitions. That is fine. The fun is in reading small signs under perfect darkness. You might capture a night that shows nothing unusual and still feel lucky. There are not many nights when the stage is this clean. There are even fewer when the stage is clean and a candidate shock is on the way. If the week passes and you catch a cut or a pivot, you will have seen the wind move something across millions of kilometers without touching it in any solid way. If the week passes and you see only a gentle rise and fall, you will have watched a relic from the early days of the system breathe under sunlight with no drama at all. Both are satisfactions, both teach. The window is not a promise of spectacle. It is a guarantee of opportunity. We have set the scene, sharpened the senses, and gathered the simple tools that can turn a clear night into a small laboratory. Before the window opens fully, we need one more element to keep our claims honest. We need a shared rule for what counts as proof and what counts as a beautiful coincidence that we let go of without regret. A good story can make any sky feel charged. Proof is less forgiving. It asks for frames and times, for signatures that travel through different instruments, and for patterns that survive the boredom of repetition. If we want to know whether the comet is answering a solar disturbance or only turning on its own axis, we need a test that a stranger could repeat next season and get the same answer. That is how we protect mystery from becoming myth. We let the night speak in numbers and in shapes that appear when and where physics says they should. Begin with prediction, then observation. We estimate when the shock front from a coronal mass ejection should reach the lanes near the comet. The estimate uses the speed of the cloud as gleaned from coronagraph views, corrected for the background wind that can slow or speed the passage. The window for arrival is not a single minute. It is a span on the order of many hours. We mark that span on a shared clock. We also mark the longitudes where the fold in the magnetic sheet is likely to run during those hours. This builds a corridor in space and in time where a coupling signal would be most credible. Next, define the signatures. The ion tail reacts first because ions tie to magnetic lines. A credible response begins within the arrival window and appears as a fast change near the head. The tail can pivot by several degrees. It can show a dark lane that opens like a zipper, a disconnection that drifts away while a fresh spine grows from the coma. Brightness can surge along a thin central filament. The dust tail should answer more slowly, or not at all, since dust listens to sunlight and inertia more than to fields. A jet-driven change, by contrast, tends to push both tails together in a smooth sweep. That difference in behavior is a key to separating engine from weather. Now, ask for coincidence across channels. If images show a pivot and radio logs show a Type 2 burst in the same broad window, interest climbs. If solar monitors indicate that a shock passed a reference location in the inner wind at a time that back projects to the comet an hour or two earlier, interest climbs again. If amateur frames from 3 continents record the same bend within a few hours of one another, interest climbs higher still. A single image can charm. A network of time-stamped records begins to persuade. Repeatability matters more than drama. One strong night can be an accident. Two nights that trace a moving front are harder to dismiss. If the tail repeats a smaller change, a rotation later in a manner that matches the beat of the sheet as it swings past, that adds a fine layer of confidence. If a different comet shows the same family of responses a month later under a different ejection, then the pattern has legs. We do not need to reach certainty that can survive a courtroom. We need to reach the honest threshold, where a careful skeptic nods and says the alignment is unlikely to be chance given the controls. Controls exist in the quiet. We should log nights with no change and note that a predicted shock passed elsewhere. We should record gentle kinks that happen long outside arrival windows. These are our nulls. They keep us from warming to noise. They teach the difference between a system that is always fluttering and a system that flinches only when touched. A catalogue of negatives is not glamorous. It is the spine that lets the positives stand upright. Caution also lives in our language. We can say that the evidence is consistent with a solar disturbance affecting the ion tail. We can say that the timing and morphology favor a coupling explanation over a rotation effect. We should not say the comet caused any flare. The arrow of energy points outward from the star. A minority view holds that small objects can tip timing in delicate systems. It remains uncertain whether that applies here. If it does, the effect would be subtle and would require statistics across many cycles, not a single week. There is one more safeguard. Share methods openly. Post raw frames or linear stretches alongside processed images. Keep the timestamps and locations visible. Mention lens and exposure. Invite corrections. The goal is not to win an argument. The goal is to build a record that anyone could use next season when a different comet writes its diary across the same lanes. If it works, the pattern will outlive this window. If it fails, we will still have a library of beautiful negatives under new moon skies. The standard is set. With it in hand, we turn to history for scenes where nature showed the tail as a windsock under pressure and the sky as a theatre where cuts and regrowth can happen in a single spin of the star. History gives us two scenes that feel like rehearsals for the week ahead. In one, a familiar short-period comet sailed through a normal patch of inner space, bright and steady, its ion tail, a straight pale blade behind it. Then a shock arrived. Cameras fixed on the object watched a thin, dark seam open between the head and the tail. The seam widened. The tail detached and began to drift away like a ribbon cut free. Within hours, a fresh spine grew from the coma and took its place. The comet had not broken. It had been edited by weather that no human eye can see, as a traveling front of magnetized plasma rearranged the field lines that the ions obey. The image sequence from that day is a masterclass in how space does violence without contact. A coronal mass ejection does not club a comet. It changes the rules the comet must follow. Ionized gas is loyal to magnetic lines. When a shock forces those lines to bend or reconnect, the loyalty remains, but the route changes. Energy is released at the reconnection site. The old tether is gone. A new one appears. The visible result is that eerie cut and the quick growth of a new tail that points along the updated flow. Dust tells a different story. It trails in a gentle curve that notices sunlight and motion, and only slowly echoes the turmoil that the ions feel. The split between these stories is the signature of a true external touch. 7 years later, a different drama unfolded at a different world. A long-period comet from the deep reservoir of our system passed so near Mars that it poured dust and gas across the top of the thin Martian air. The planet became a laboratory in that hour. The upper atmosphere lit with exotic ions. The distribution of particles shifted. Instruments recorded a temporary rise in metal species that do not belong in that air. Heating in the high layers increased for days. Nothing on the ground changed for people who might someday walk there. The event was a kiss at the edge. Yet it proved that even a small icy body can write a clear line across a planetary environment when geometry is precise and timing is right. Together, these scenes press a lesson onto the present. Comets are more than pretty visitors. They are mobile factories of plasma and dust. They respond to the wind with a sensitivity that can turn otherwise invisible structures into visible strokes. They also carry enough material to perturb a nearby environment when the pass is close. These are not speculations. They are demonstrations that astronomers have watched and measured. The open question is not whether comets can be shaped by the solar wind or whether they can shape a thin atmosphere. Both are true. The open question is how often the most dramatic versions appear. That depends on the strengths and angles of the players, and it depends on luck. The week that now approaches is not a duplicate of 2007 or 2014. It is a new alignment with its own quirks. The shock from the recent solar event may or may not persist with integrity through the relevant longitudes. The sheet may be quiet or wrinkled. The comet may continue to outgas strongly, or it may settle. The interstellar traveler will pass near Mars, but not with the intimacy that drove that earlier shower of metal ions. These differences matter. They set our expectations on a calm line, yet they do not drain the scene of promise. Even a modest shock can create a visible disconnection. Even a modest coma can register in sensitive instruments. The echoes matter most as reminders of what to watch for. A cut that moves outward from the head, a new tail forming with steady resolve. A temporary change in the way a planet breathes when dust and ions arrive in bulk. These are the signposts that nature has written for us before. They are likely to be written again in some season, if not in this one. The value of memory is that it keeps our eyes gentle and our claims precise. We can name the patterns without declaring them inevitable. We can honor the past without forcing the present to copy it. With these echoes in mind, we step back from spectacle and face a quieter challenge. Human minds fall in love with patterns. When the sky obliges with a cluster of events, we can begin to hear intention where there is none. The next part asks why some sequences feel impossible to ignore and how to keep that feeling from driving us past the boundaries that good thinking sets. There are seasons when the sky arranges its pieces so neatly that even the calmest minds feel a quick intake of breath. Years ago, a visitor from outside our system swept close to the sun, while unusually strong solar flares rolled through. In the same window, a major earthquake struck on Earth. The overlap felt like a riddle written in fire and stone. People drew lines between the events in late-night posts and early-morning op-eds. The images were vivid. The numbers were close enough to sit on the same page. The question was obvious. Did space weather pull a hidden lever under our feet? Or was the sequence a coincidence that only looked meaningful because we watched it in slow motion? Institutions that keep score in hard times gave a clear answer. Geological agencies restated the position that earthquakes arise from stress, along faults that load for years and release in minutes. Solar flares and geomagnetic storms affect radio, satellites, and power lines, but they do not have a demonstrated pathway to trigger tectonic failure. The language was conservative, as it should be. It did not claim that some subtle influence could never exist. It said that the available data do not support a causal link. That distinction matters. It is a guardrail for the part of the mind that loves drama. It is also an invitation to anyone who believes there is a link to present a test that can survive quiet seasons as well as loud ones. Why do such clusters lodge in memory? Partly because the brain is a hunter that evolved to connect dots. A rustle, a shadow, a second rustle. Better to assume a pattern and be wrong than to miss a predator and be right only once. That habit still serves us in science when it points to a test that can be run later. It misleads us when it closes the loop too soon. The sky provides many draws from many decks. When you pull often enough, rare hands appear. 2 flares, a notable visitor, a quake. The stack looks designed because it fits onto a single calendar. The truth of large numbers is less cinematic. Unusual overlaps are inevitable when the sample is huge. We can respect both sides. The storyteller in us can feel the pressure of a sequence. The analyst in us can ask for a rule that does not crumble when the news cycle moves on. That is the balance this film has tried to keep. We bring the spectacle forward. We set the questions on the table. Then we insist on tools that can measure quiet nights as well as thrilling ones. That balance does not squash wonder. It saves it from turning brittle. There is another feature that makes these sequences feel designed. The human sensorium prefers endings. When events stack, we reach for a last page that explains them. If no clean cause appears, frustration arrives. A neat story with no driver feels wrong. Yet science often leaves stories open. It favors inference over closure. It lets absence carry weight. In the 2017 sequence, the absence of a proven path from solar storms to fault rupture speaks loudly. It does not insult curiosity. It tells curiosity where to dig next, which is in archives, not in headlines. How does this bear on the current window? It tells us to prepare for both outcomes and to value them equally. If the comet's ion tail shows a crisp reaction that lands in the window predicted by a traveling shock, we will have a living diagram of coupling between a solar disturbance and a plasma structure. If the tail stays calm through the dark, we will have a constraint that pushes the conversation back toward internal plumbing and away from environmental forcing. Both paths produce knowledge. Both reduce the room for stories that lean too hard on feeling. There is a quiet comfort in this posture. It releases us from the pressure to solve a universe-sized riddle in a week. It lets us become careful collectors rather than professional exclamation points. It also protects the people who watch for hazard. When we talk about earthquakes or power grids, we keep the language tight. Preparedness does not need coincidence to justify itself. It is justified by the long record of the planet and the sun acting on their own clocks. A clear lens on risk helps audiences enjoy the sky without picking up a fear that does not belong to them. By this point, you can see the through line: known against unknown, pattern against chance, test against tail. The next piece of the story brings us back to the star itself, because the background mood of the sun sets the baseline for every scene we have watched. The current solar cycle is not the sleepy one many expected. It is louder, busier, and more generous with flares and plasma clouds. That matters for our comet, for the traveler behind the glare, and for anyone who wonders what the next months may bring. We step now into that broader weather report and ask what an energetic star does to a fragile tail and to our hopes for a clean experiment. The sun is louder than the forecasts that set expectations a few years ago. Spot groups rise and persist. Flares pop with a cadence that keeps technicians on their toes. Clouds of plasma lift from the corona and roll into interplanetary space like slow tsunamis that never break. This is the rhythm of an active cycle, and it forms the stage on which our comet plays its brief role. When the background is restless, small dramas have more chances to unfold. This does not promise spectacle. It raises the odds that a careful observer will catch a clean exchange between the wind and a fragile tail. Cycles have personalities. Some glide with modest highs and lows. Others climb to noisy crests that fill the radio bands with static and the polar skies with color. The current crest is not unique in history, yet it exceeds the softer pattern that many models predicted not long ago. That mismatch matters for spacecraft operators and grid managers. It matters for storytellers because it means we do not need to reach for exotic drivers to explain a busy month. A lively sun can do that alone. It also means our test sits in a context that is favorable. Shocks are more common. The sheet is more wrinkled. The lanes where the comet travels are more likely to host the kind of structures that write themselves onto tails. There is a temptation to treat activity as menace. The truth is more nuanced. Most flares produce radio blackouts that inconvenience pilots and enthusiasts more than anyone else. Many mass ejections miss Earth or glance by with a light touch that makes for pretty curtains of aurora and little more. Severe storms are rare. They deserve respect and preparation. They do not justify fear as a default mood. This distinction lets us keep the tone of the story steady. We can talk about charged weather with excitement and with care. We can cheer for a tail disconnection without implying harm to homes and hospitals. An active cycle also teaches humility about prediction. Even with a decade of advances in observation, the exact timing of a major flare is hard to call. We can measure how twisted a magnetic region looks. We can watch it evolve as the surface rotates. We can guess that tension is building and that an eruption is likely in coming days. We cannot say which hour will hold the flash. That is why the plan for the comet does not rely on a precise alarm. It relies on a window, a range of nights when the stage is dark and the path is favorable. Within that span, nature chooses the beats, and we accept the role of patient witness. For the comet, a busy sun is a louder teacher. The ion tail becomes a thin needle in a vibrating field. Each ripple can sway it by a small amount. Each crossing of the folded sheet can turn it more decisively. If a genuine shock crosses the lane, the response can be theatrical, even at modest speeds. The dusty coma will answer in softer ways. Brightness can rise with heating. Jets can come and go as the nucleus rotates. Those changes write a parallel story that must be separated from the wind's touch. The beauty of an active cycle is that it offers multiple dances to compare. A slow pivot one night, a sharper kink the next, perhaps a clean cut if luck and geometry agree. From that sequence, we can sort the internal from the environmental with more confidence than a single quiet night would allow. The visitor behind the glare shares the same ocean. If it grows a coma, it will feel the same folds and gusts, even if we cannot see the play in real time from Earth. Mars may catch a hint. Later, when the glare eases, we might catch a late echo of an earlier push, a light curve that does not rise smoothly, a tiny deviation in track that suggests outgassing at peak heat. None of these signs will settle debates about deep coupling. They will sharpen a picture of how different bodies, native and interstellar, answer the same weather. A rising cycle changes expectations for aurora too. Viewers far from the poles may see curtains where none usually appear. If storms stack, they can combine in ways that produce brief nights of vivid display at lower latitudes. This is the friendly face of a restless star. It invites people outside to look up and join a conversation that often happens only in labs and control rooms. The comet becomes a pointer, the visitor becomes a rumor, the sky becomes a stage set for shared watching. Through all of this, caution keeps our language clean. We do not assign intention to a star that follows plasma and field. We do not turn a season of activity into a forecast of catastrophe. We present a weather report with clear notes on what is likely, what is possible, and what would be unusual. That posture keeps trust with an audience that wants wonder without alarm. It also keeps faith with the method that will guide the rest of this film. We will set risks in plain terms, then fold them back into the story so that awe can breathe. The cycle is rising. The nights of the new moon are near. Our comet is awake. The visitor is closing on its warmest hours. The wind is gusty. The map of the sheet looks lively. All signs point to a week when the patient can gather strong negatives or catch a real signature. Either outcome will be a step toward clarity. With that frame in place, we turn to hazard in plain language, the kind that respects the limits of what storms can do and the very real reasons to prepare for the few that press harder than most. Risk sits in the background of every sky story. It is the soft drum that keeps time while we talk about light. When the sun is busy, people ask the same question in different voices. Should I worry? The honest answer begins with scale. Most solar events are small enough that they touch our lives as brief radio hiccups, faint navigation jitters, and lovely curtains of aurora that flow across high latitudes. These are interruptions rather than disasters. Pilots and controllers work around short radio blackouts. Satellite operators adjust. Power grids hum along untouched. The sky performs, then it sleeps. There are outliers. A strong storm can push currents into long wires on Earth. Transformers can feel that stress the way a tree feels a steady wind. In rare cases, hardware can overheat and fail. Modern grids in many countries carry sensors and procedures that lower exposure when a forecast hints at trouble. Operators can reconfigure, shed load, and watch the meters with extra focus. Most of the time, the storm does not deliver its worst. The preparation still matters. It turns a possible problem into a routine. The lesson is simple. Preparation beats prediction because prediction is a blunt tool for timing exact hours. We can know that a storm is likely to arrive in a day. We cannot promise what mine it will feel it most. Satellites live in a more direct stream of charged particles. Their electronics can be upset by energetic hits. Designers know this and build shields and redundancy into critical systems. When the flux rises, operators can place spacecraft in safer modes. Small satellites and aging platforms are more vulnerable. Yet even in strong events, the count of permanent losses is smaller than alarmed headlines often imply. The hazard is real. It is managed through design, procedure, and experience. This is why the tone in a responsible report feels steady. We respect the storm. We do not adorn it. For people far from the poles, the most visible effect of a lively sun is the aurora that occasionally steps into lower latitudes. This is the friendly side of space weather. It is a public performance that needs dark skies and patient eyes. If the indices climb and the forecast maps stretch toward your region, a short drive away from city light can turn a night into a memory. Cameras see the glow better than eyes at first. Long exposures pull color from the faint curtains. The show has no ticket price, and often no warning. The right choice is to keep a bag packed and a thermos ready when a forecast hints at a chance. There is a temptation to link solar storms with earthquakes or volcanoes, because the images can align on a calendar and the emotions can rhyme. The scientific position from agencies that study the ground is consistent. Tectonic events arise from stresses loaded over years. They release when faults reach failure. No demonstrated pathway shows that geomagnetic storms trigger that release. It is possible that the upper air can whisper to systems that are near their own thresholds. It remains uncertain whether any effect exists that would matter beyond statistics that feel thin. Preparedness for earthquakes depends on building codes, drills, and local history. It does not depend on space weather alerts. Keeping these domains separate protects clarity. What then should a person do during an active window? The list is short and calm. If you run equipment that is sensitive to power quality, use surge protection. Save work often. If you travel by air and you rely on high-frequency radio, expect occasional reroutes. If you live in a region that sometimes sees aurora during strong storms, follow a trusted forecast and keep fuel in the car. If you manage infrastructure, you already receive technical bulletins that explain how to reduce exposure. The rest of us can go outside and enjoy the sky. Risk language can carry theatre. We will refuse that path. We will also refuse the opposite error, which is to wave away the possibility of rare harm. The middle line is patient and plain. There are storms that can break things. They are not common. The sun this season is energetic. That raises the count of small events and the chance of a moderate one. If a strong compound storm arrives, services might slow or flash off at the edges. The world will not end. The next day, people will repair and resume. This is not defiance. It is the track record of a planet that has ridden a living star for a very long time. Now fold this back into the comet. A tail that kinks or breaks is not a warning to the grid. It is a message about fields and flows. It is an index card pinned to a board the size of the inner system. We read it for what it says about coupling and timing. We do not read it as an omen. With that separation clear, we can return to the most enticing question of all. Can small players ever leave small marks on larger systems through timing alone? Some see the hint of a bridge, others see only coincidence. In the next part, we walk to the edge of that bridge and ask what it would take to stand on it without stepping into fantasy. Call it a rumor in the physics of space. The idea that a comet can become more than a passenger, that for a brief moment it can behave like a small electrode in a grand electrical system. It sounds romantic. It might also be partly sensible if we keep the claims modest and the checks strict. Space is not empty. It is a thin ocean of charged particles and magnetic fields. Currents flow in that ocean. Boundaries form and break. In such a setting, a dense pocket of fresh plasma, seeded with dust and threaded by field lines, can sometimes organize itself into layers where charge separates. Those layers create electric fields. Electric fields drive currents. Currents invite feedback that can reshape the pocket again. This is not a power plant. It is a whisper that can be heard when the room is already very quiet. One possibility is that an outbursting comet builds small double layers in its coma. In a laboratory, dusty plasmas do this often. Charged grains collect, a small potential forms across a thin region, and the flow around it changes course. In space, the same dance could happen on a larger scale, but still within the fragile envelope near the nucleus. If the comet sits near a fold in the heliospheric sheet, the local structure might couple more efficiently to the wider flow. The result would be a pocket that resists or redirects the wind with slightly more vigor than a simple neutral cloud could manage. Downstream, the effect might look like a shift in how the ion tail detaches and reforms. Upstream, it could look like a faint imprint in radio signatures if coherent oscillations arise in the layers. A competing view suggests that this is reaching too far. The mass and energy of the sun dominate so completely that any current sourced in a comet's skin would be drowned out before it mattered. That view is sensible, and it keeps us from inflating the role of a small body into something it cannot be. Yet complex systems allow another reading. Timing can magnify small inputs if the background is near a threshold. Consider a magnetically stressed region on the sun, one that is already close to letting go. It remains uncertain whether a tiny perturbation from afar could tip that balance by a minute or an hour. If such a whisper exists, it would be statistical, not cinematic. You would not see a flare launch the instant a comet sneezed. You would see a slight bias in when an eruption chose to happen across many similar situations. If bridges exist, they should leave testable signs that do not depend on one night. You would expect weak but repeatable timing correlations between comet outbursts and small changes in radio or particle measurements along the magnetic path that connects the comet's region to a solar active zone. You might find narrow-band radio tones from the cometary coma that drift in step with field changes measured nearer to the star. You might see tiny non-gravitational shifts in a comet's track that coincide with periods when coherent currents are suspected, although such shifts have simpler explanations that must be ruled out first. None of these signs would be loud. They would live close to noise and would demand patience and large samples. What would falsify the bridge idea? If careful statistics across many apparitions show no timing bias at all, then the case weakens to the point of romance. If radio and particle instruments fail to see any linked behavior when comets cross current sheet folds during active times, then the corridor looks empty. If laboratory studies continue to show double layers in dusty plasmas, yet space never echoes those structures in the data, then the translation from bench to sky fails, and we must accept that scale has defeated the analogy. It is also possible that bridges appear only in special geometries. A comet would need to be both energetic and well-placed, near a fold where fields are already rearranging, and during a season when the star is restless. The current window offers a version of that setting. Our comet has woken. The sheet is lively. The star is active. A visitor from outside moves through nearby lanes. Even with all that, the most we should expect is a clearer record of how the wind touches a tail. Anything beyond that belongs to the slow work of comparing seasons, not the quick thrill of a single week. Language can protect us here. We can say that a comet may act as a sensitive antenna. We should not say it acts as a transmitter that steers the Sunday. We can say that dusty plasma can form structures that couple more strongly to the wind. We should not claim that such structures drive events at the star. This keeps wonder alive without letting it swell into myth. It also keeps the focus on what the next nights can actually deliver. A tail that cuts cleanly when a shock arrives, a pivot that matches a fold, a sequence that repeats as the sheet swings by. These are bridges we can step on with confidence. In the next part, we turn from ideas to fingerprints. If a faint coupling exists, even one that only governs timing at the margins, it should produce specific clues. We will name those clues and place them where cameras and clocks can catch them, so that the sky can give us an answer that is as plain as a line in a logbook. If a weak bridge exists, it will not shout. It will leave fingerprints that look ordinary until you stack them in the right order. Our job is to set the paper and the ink. Then we ask the sky to sign or to leave the page blank. The first fingerprint is time. A coronal mass ejection launches, and its shock moves outward through a changing wind. We estimate a travel window to the longitudes where the comet will be. That window is not a single moment. It is a span with soft edges. Inside that span, the ion tail should show a fast change near the head. The change can be a pivot that happens too quickly to be a slow jet effect, or a thin, dark lane that opens and slides away as a detached segment fades. If such a sign arrives well outside the span, we mark it as plumbing, not weather. The second fingerprint is sequence. The ion tail should answer first, because ions listen to fields. The dust tail should follow, later, if at all, because dust listens to sunlight and inertia. In practice, this means that the thin, straight tail near the head will move or thin before the broader curved tail seems to notice. If both tails sweep together in a single motion, Rotation is the better explanation. If the ion structure jerks while the dust remains calm, space weather steps forward as the likelier cause. This ordering turns a pretty picture into a test. The third fingerprint is echo. A shock that crosses the sheet can produce radio signatures that sweep through frequency as it walks outward. A Type 2 burst is the classic sign. If the radio logs show such a slope during the same broad window when the tail reacts, the case gains a new pillar. If the radio logs are quiet while images suggest disconnection, we slow down and look for other causes. Not every shock will sing for every listener, but the overlap can push the pattern away from coincidence. The fourth fingerprint is drift. Non-gravitational pushes can move a comet or a visiting body by tiny amounts that reveal when jets turned on. This is a slow yardstick compared to the minute-by-minute life of a tail. It can still offer a check. If timing of small orbital deviations lines up with episodes of increased tail structure near predicted crossing windows, the picture gains depth. If there is no match across a season, we accept that internal engines and external gusts were playing different songs. There is also a negative fingerprint that matters just as much: silence. If the window passes with no tail change while radio logs show a clean shock in transit, we learn that the structure was too weak or too misaligned to touch this object. If many such windows pass with many comets and many shocks, and we still see no clean events, we learn that coupling is rare or that our eyes have been chasing phantoms. Silence deserves as much ink as spectacle, because it defines the limits within which our stories must live. To make these fingerprints legible, we need discipline. Cameras should record short sequences with accurate time. Observers should note position angles of the ion tail relative to stars that can be identified later. Simple photometry can track brightness along a thin central line in the tail. Radio logs should save raw plots, as well as annotated summaries. Solar monitors should note the hours when a shock passes, known reference points closer to the sun, so that arrival times near the comet can be back-projected with less guesswork. None of this requires a cathedral of equipment. It asks for patience and for an agreement to write details down. Laboratories can help by showing what dusty plasmas do under controlled conditions. They can test how double layers form and how they oscillate when a flow changes speed. They can show which signatures are robust and which are fragile. These experiments do not decide what happens in the sky. They educate our eyes so that we do not declare a delicate embroidery to be the mark of a storm. They set expectations. They also protect us from flights of imagination when a pattern of beads along a jet tempts us to read more than the physics allows. A competing view suggests that even perfect fingerprints would only prove that the wind can move a tail, which we knew already. That is fair. The novelty here is not that the wind touches the tail. It is whether timing across many events hints at a faint bias that a sensitive system might impose. It remains uncertain whether such a bias exists at all. If it does, the signs will be statistical. The right response is to collect carefully, compare seasons, and accept that a single window can only begin the work. With our test now written in the simplest possible language, we can face the most alluring detour of the season. People want to link the electric life of space with the solid rumble of the ground. In the next part, we step into that debate with respect for curiosity and with the guardrails that years of careful study have placed around it. Every few years, a cluster of sky events shares a page with a major earthquake, and the thinking mind reaches for a bridge. The image is too tempting. A solar storm rolls across the news, a bright comet gains a tail, instruments chatter, then a fault slips beneath a continent. It feels like cause and effect, lightning and thunder, even when the distances are absurd and the systems different. The temptation is strong enough that entire literatures sprout around it. Some papers report hints of electrical changes in the air before quakes. Others find no such consistency. Agencies that hold responsibility for public guidance keep their message steady. Tectonics run on their own clocks. No demonstrated link shows that space weather pulls a trigger on the ground. Curiosity does not end there. A minority view holds that the Earth, the air, and near space can couple in subtle ways. Charged layers in the ionosphere can respond to changes in the solar wind. Stressed rocks can generate weak fields and currents before they fail. Some satellites have recorded ionospheric anomalies before large quakes. It remains uncertain whether those anomalies are reliable precursors or only coincidences that stick in selective memory. The energy mismatch is a wall that every such idea must climb. The mechanical forces in a major rupture dwarf the electrical whispers of space weather. The proposed path, if any, would be a small nudge to timing, not a switch that makes an event happen. Why does this matter to our story? Because the week we are entering will generate talk. A strong flare here, a change in a tail there, and a quake somewhere in a tectonic belt, and the posts will write themselves. We can prepare viewers to handle that flood with poise. We can say plainly that no proven mechanism connects space storms to fault failure. We can encourage a habit of looking for long records rather than single nights. We can also keep room for honest study. If ionospheric changes do precede some quakes, the path to understanding them runs through years of quiet monitoring, not through linking dramatic events after the fact. Preparedness language helps. If you live in a quake country, your safety depends on codes, on securing heavy furniture, on drills, and on community planning. It does not depend on a solar forecast. If a quake happens during an active sky week, your actions will be the same as they would have been in a quiet week. Drop, cover, hold on, help your neighbors, check gas and water lines. This sounds banal until you need it. Separating spectacle from safety gives people permission to enjoy the sky without a knot in the stomach. It also builds trust in the storytellers who respect the difference. There is a second benefit to this discipline. It protects the wonder we came for. When every cluster is treated as a sign of hidden control, curiosity curdles into fear. When we acknowledge that the strongest story may be no story at all, we regain the freedom to look up with joy. The comet's tail can be a windsock without being an omen. A bright flare can be a space weather event without being a prophecy. The ground will move on its own schedule, which is hard enough to understand without adding thunder from the Sunday. If a real relationship between space weather and earthquakes exists, it will look like a small statistical bias that repeats across many cycles. It will not look like a magic week when everything lines up and fate taps the table. The search for such a bias belongs to seismologists and atmospheric physicists, with data sets that stretch across decades. Our role is to avoid amplifying claims that have not passed that test. It is also to keep an eye on the research with an open mind. Science has room for surprises. It does not have room for stories that do not survive the quiet seasons. As we step back from the boundary between sky and ground, we turn again to the test that the cosmos is about to offer us. We have a comet that is awake, a shock that may be on the way, a visitor that approaches its warmest hours, and a star that runs hot. The stage is set for a 7-day experiment that belongs to anyone who wants to go outside and look. In the next part, we draw the plan again, not as a list of instruments, but as a short ritual that night watchers can repeat, so that the record they build will be beautiful and also useful. A laboratory is opening above your head. No ticket, no walls, only a schedule written by the sun and the slow glide of a comet. The test is simple by design. Watch a fragile tail in the quietest nights of the month. Note when it bends, when it frays, when it shines along a thin spine as if a wire inside has lit. Compare those moments with the expected passage of a disturbance launched days earlier from the bright limb. If the moments match more often than they should by chance, curiosity grows into a case. If they do not, the case dissolves into a stack of lovely negatives. Either outcome is a result. Either outcome respects the sky. Treat the week like a ritual. Pick a place with a low horizon and dark air. Arrive before the target rises. Give your eyes time to adapt. If you have only your senses, you can still learn. Fix the position of the comet against a bright triangle of stars. Stare softly. Look for a thin line that points away from the sun and a thicker curve that bows to the side. If you notice a sudden tilt in the thin line, mark the time in your head and repeat it into a voice memo before it fades. If you have binoculars, sweep with small motions. If a camera is in your kit, mount it steady and take a string of short exposures with accurate time. Do not chase perfection, chase consistency. The experiment does not end at the eyepiece. It lives in the habit of record keeping. Write the date in universal time. Note your latitude and longitude. Record the lens and exposure. Keep a raw version of each frame along with any processed view. In the morning, place the images beside a simple plot of solar radio logs and a public estimate of shock arrival times. You are not proving a theory alone. You are adding a square to a quilt that will be sewn together by people you will never meet. This is the old joy of skywatching, updated by a network that can move images across oceans while the dew is still on the grass. Bias is the quiet enemy. To keep it at bay, decide your thresholds before the week begins. Promise yourself that a single pretty kink will not count as a signature. Promise that you will look for the sequence that favors ions over dust, a fast change near the head that is not echoed at once in the broader curve. Promise that you will weigh nights of calm as carefully as nights with gossip. Place reminders where you will see them. The best observers are not the ones with the biggest gear. They are the ones who keep their promises to the method when excitement tries to bargain them down. Patience is a tool as real as a lens. A shock may arrive late. It may pass above or below the lane the comet occupies. The sheet may be smooth that night, then riotous the next. A traveler from outside may give Mars a better show than it gives Earth. Accept these contingencies ahead of time. They are not flaws in the test. They are part of the test. We are not in charge of the variables. We are in charge of how we respond to them. That response will read as calm in your notes and as clarity in this story. There is a way to fold wonder into discipline so that neither breaks. Begin each night with 1 minute of silence. Look at the stars without an agenda. Then turn to work and take the frames. End with 1 more minute of silence. Commit to sharing whatever you found. Put the folder in a place where others can see it. Invite corrections with grace. Thank people who find your mistakes. If you caught a rare disconnection, you will have witnesses. If you did not, you will have done something better. You will have made the negative space that surrounds any positive result. Science is a sculpture that needs both. The test belongs to more than amateurs on hillsides. Professionals will point radio dishes at the sun and watch for sweeps that betray moving shocks. Spacecraft will log flows and fields near Earth. Solar imagers will trace loops on the star that shed light on the origins of the disturbance. The comet is the common meeting point. It is the point of translation where physics that feels abstract becomes a visible gesture that anyone can read. That is the secret motive of this film. To turn a file of plasma parameters into the sight of a tail that snaps and regrows like a living thing. There is a sentence that ties the whole through line together. Known against unknown, test against tail. We are not promised a dramatic answer. We are promised a clean chance to ask a fair question. The week is the instrument. The comet is the needle. The sun is the drummer that may or may not hit the beat we expect. All that remains is to invite everyone who cares to stand outside and listen with us. In the next part, we hand you a simple manual that turns curiosity into data so that your photos and notes can travel farther than your own hard drive, and so that a stranger under a different sky can build on what you began. Begin with the promise that your notes can matter. A clear night and a patient eye can turn a backyard into a small station in a global network. You do not need rare equipment. You need a steady place to stand, a view that reaches low toward the horizon, and a habit of writing things down while they are still fresh. The comet will not wait for you to fumble with settings. Decide what you can do before you step outside. A simple plan beats a complicated dream when the clock is running. Find the comet on a chart in daylight. Learn the pattern of nearby stars so that you can recognize the field at a glance. When you arrive on site, give your eyes time to dark adapt. Shield them from phones and car lights. Sweep slowly with binoculars if you have them. Look for a soft green haze that sits where the chart said it would. Once found, settle in and study the shape. The thin tail that points away from the sun is the ion blade. The broader curve that bows to the side is the dust. Train your attention on the meeting point near the head. That hinge is where fast changes will first appear if space weather pays a visit. If you have a camera, treat it like an instrument rather than a trophy maker. Mount it firmly. Use a short lens if the sky is moving too fast for long exposures. Take a short test at high sensitivity to confirm the field. Then collect a sequence of frames at regular intervals. A steady cadence is more valuable than one heroic exposure. Timestamps are gold. Set the clock to universal time before you leave the house. Speak the time into a voice memo as you shoot if you need a backup. Keep raw files. Keep a simple log that pairs frame numbers with your spoken notes. If a change appears, resist the urge to chase it with wild adjustments. Hold your plan. Take the next frame on schedule. Then the next. The goal is to capture a history, not a single masterpiece. If the thin tail pivots by a few degrees, say so into your recorder. If a faint gap opens between the head and the tail, say so, and mark where the detached piece is headed relative to a nearby star. If nothing happens at all, say that too. A quiet night with clean frames is a gift to the future, because it fills in the map of when the comet did not respond. Sharing multiplies the value of your work. After you warm your hands and check your focus, place your images on a public folder with clear labels. Include your location, the times, the lens and exposure, and the sky quality as you judged it. Pair the images with a short paragraph that says what you saw and what you did not see. Do not over-process the frames. Offer a gentle stretch that keeps faint structures honest. Post 1 or 2 examples that show the feature you want people to notice. Offer the raw stack to anyone who asks. Corrections are part of the ritual. Welcome them. The aim is a trustworthy record that strangers can use without guessing what you did. Context turns pictures into evidence. Before bed, check public solar radio logs for the hours you observed. Note whether a Type 2 or Type 3 burst was reported. Glance at space weather summaries that estimate when a shock might reach the relevant longitudes. Do not bend your notes to fit the summaries. Keep your record straight. Simply write that the comet was calm during a predicted window or that it twitched during a quiet hour. Over months, and across many observers, these pairs of statements will decide whether the pattern exists. Safety and courtesy matter. Choose legal viewing spots. Respect neighbors and wildlife. Bring warm clothing and a light with a red filter. Pack out what you bring in. If you watch with children, give them the role of timekeeper or note-taker so that patience becomes play. If you visit a club night, contribute your frames to the group archive. The sky belongs to everyone, so should the record of what it did. The last instruction is the simplest. Let wonder be the reason you are there, and let discipline be the way you honor it. You may catch a clean disconnection that lands exactly when a radio slope says a shock was passing. You may capture nothing but a beautiful veil under a new moon. Both outcomes are wins. Both add to a story that no single person can write alone. Your part is to be present, to be careful, and to share. In the next part, we will talk about how to keep the joy of mystery while holding our language to a higher standard than the internet usually demands, so that the audience can trust the ride even when the answer is no. There is a point in every sky story where excitement tries to outrun evidence. It happens when a single frame looks strange, when a headline uses the word destroy, when a graph slopes just so. The internet rewards speed and volume. Science rewards patience and clarity. The line between them is not a fence. It is a balance beam. Walk it well, and the audience feels both wonder and trust. Slip, and the mood turns to suspicion or fear, and the signal we hope to study becomes another flare of noise. Start with language. Say what you saw, rather than what you wish you saw. A thin tail pivoted by several degrees within an hour. A faint gap appeared and moved outward. A radio plot showed a slow slide during the same window. These are descriptions. They invite others to check and to add. Avoid words that assign motives to objects. The comet did not try to dodge a shock. The sun did not aim at anything. Keep verbs that belong to fields and flows. They are beautiful enough. Hold claims to the height of their evidence. If one site shows a kink but 2 others do not, mark it as uncertain. If a feature survives in raw frames from several observers, raise confidence but still resist superlatives. If the timing lines up with a predicted arrival window, say consistent with rather than caused by. These small choices keep a door open for later correction without making early records timid or vague. They also lower the temperature when the story crosses into news feeds that flatten nuance. Context protects meaning. A tale can change because a jet rotated into view. A camera can produce artifacts that imitate ribs or gaps. Thin clouds can fake structure. When you share an image, include nearby stars for scale. Include a frame from the previous night for comparison. Include the exposure and the lens. These details do not slow a viewer who seeks wonder. They anchor a viewer who seeks truth. They also signal to editors that you are a reliable source, which matters when they must choose which pictures to amplify. Resist the lure of grand theories in hot moments. A dramatic week can tempt anyone to connect distant events. When a quake occurs during an active sun, people will draw lines. You do not need to argue with strangers. You can steady the conversation by repeating the core positions from agencies that study the ground and the sky. No demonstrated link connects geomagnetic storms to fault failure. Preparedness stands on its own. This calm sentence does more to cool frenzy than a dozen threads of debate. It also models how to hold two truths at once. The cosmos is full of surprises. Not every overlap is a sign. Let silence be part of the show. A week of perfect darkness with a steady tail is a result, not a failure. Share it with the same pride that you would a cut or a pivot. Explain that nulls define the frame for any later positive. This habit teaches audiences that science is not a parade of fireworks, it is a long walk in good company. It also helps when a real signature arrives, because your feed will not look like a machine that only prints exclamation points. Editors, hosts, and creators face a special challenge. Short clips prefer loud claims. Algorithms reward mystery that never closes. You can still bend the medium toward honesty. Lead with the image. Place the measured sentence beneath. Promise a reveal, then deliver the record rather than a theory. Invite viewers to watch again tomorrow. The slow drip of disciplined wonder builds a different kind of audience, one that will stay when the show turns quiet, and one that will notice when the sky finally speaks loudly enough to change a mind. Our through line remains steady, known against unknown, test against tail. With the balance beam in view, we step into the countdown itself. The dates are set, the nights are arranged. The possible signals have names. Now we watch to see whether the sky chooses a loud answer, a quiet answer, or a lesson in patience. The week opens like a slow drum. On the 19th, the comet clears the horizon under a sky that feels deeper than a week ago. The tail looks steady, a thin blade inside a soft veil. Nothing in that first glance declares a test, yet the calendar hums in the background. The disturbance launched days before should be well into the inner lanes by now. If it keeps its shape, if it rides the same folds that the comet must cross, then the first nudge could appear at any hour. Patience is the only tool that works on day one. Watch. Record. Say what is there. On the 20th, small hints tempt the eye. A jet near the core sharpens. A faint rib appears and fades. These are the signs of a living nucleus turning under steady heat. Useful, yet not the signatures we wait for. The thin tail, which is the honest needle for work like this, holds its aim with no sudden pivot. Radio logs show a minor slide at dawn. The fit is not clean enough to claim. We mark it, then set it aside. The lesson repeats. One night deceives. 2 nights begin to speak. The 21st is the center of the window. New moon darkness is complete. The comet reaches one of its closer points to Earth. The veil around the head looks larger because the geometry now favors us. This is the night when even modest optics can turn a suspicion into a line. During the first hour, the ion blade tightens and appears to brighten along a narrow spine. Then, near local midnight, a tilt shows at the hinge where tail meets coma. It is not smooth, it is quick, several degrees in a span that a jet could not sweep so fast. In the minutes that follow, a thin dark lane seems to open and begin to slide downwind. You speak the time, you keep the cadence of frames. You do not chase. You let the clock and the sky do the work. Reports begin to echo online as morning creeps into other longitudes. A watcher far south posts a short sequence with the same tilt, offset by hours that match the curve of longitude around Earth. A station in the north notes a slow radio slope that overlaps the window by a generous amount. The signs are not a triumph. They are a chord that makes pund sense when heard together. The 22nd arrives, and the cut, if it was a cut, now floats farther down the tail as a fading strand. A fresh spine grows from the head with a poise that looks rehearsed. The comet breathes. The wind moves on. The 23rd is quiet. The ion blade returns to a stable aim. The dust arc continues its gentle curve. A bright jet rotates into better view and puts on a show for photographs. The contrast is useful. It reminds the eye that internal plumbing writes a different kind of change. Slow, predictable, tied to the body rather than to the river it swims in. The 24th brings another fold in the sheet across the lane. A small pivot returns, less theatrical than the 21st, yet still quick enough to deserve ink. The radio logs are thin that night. The overlap is weaker. The record remains honest. We write what happened and what did not. By the 25th, the traveller behind the glare nears its warmest days. News from Mars, if it comes, hints at faint gases and a light curve that swells with a patient rhythm. The interstellar story remains a whisper, yet it gives the comparison we wanted. One body, loud under the new moon. One body quiet under the same season of wind. The 26th seals the window. Clouds roll over some sights. Others clear at the last minute, as if the sky understood that a curtain call was due. The comet glows with confidence and throws a longer dust arc. The ion tail holds steady. No cut, no pivot. Only a clean line that refuses to make promises it cannot keep. A single sentence holds the week together. When the stage was darkest, the comet acted like a needle that felt at least one passing touch and then returned to calm. The count of days reflects the through line we set at the start. Known against unknown. Test against tail. The next part is the moment of answer. We gather the frames and the times. We stack the radio notes and the simple models of travel. We ask the question with less heat and more light. Did the sky choose choreography, or did it choose noise that only looked like music from a distance? We lay the week on a table and let the records speak. Frames from the 19th through the 26th line up in quiet order. Timestamps sit beneath them like bar numbers under a score. Radio plots fill the margins. A simple model of travel time for the earlier solar disturbance runs along the top as a soft grey band. We look for harmony rather than volume. Did the comet move when the band said a touch might arrive? Did the radio listen at the same hour? Did the changes prefer ions over dust? These are the questions that matter more than adjectives. On the central night, the answer tilts toward yes. The ion blade pivoted by several degrees in a span too quick for a rotating jet. A thin, dark lane opened near the hinge and began to drift away downwind. Dust did not answer at once. The broader arc kept its soft curve. Two observers far apart saw the same motion within a window that fits the expected arrival of a passing front. A radio log from another longitude recorded a slow downward slide that suggests a shock walking outward. Each thread alone is small. Together they form a cord strong enough to tug at doubt. The day after, the comet behaved like a patient that has responded to a stimulus and then reset. A fresh spine grew from the coma and took the place of the detached segment. The position angle of the ion tail returned to its earlier aim. Dust continued to glow with a rhythm set by rotation rather than by weather. Later nights offered smaller echoes. A brief pivot that matched a fold in the sheet. A quiet evening when nothing unusual happened while models still allowed a late arrival. These mixed signs keep our language honest. They push us toward words like consistent with and away from caused by. The verdict is not a headline. It is a statement that a careful skeptic can accept. The evidence from this window is consistent with a solar disturbance altering the ion tail of the comet near the predicted time of arrival. The morphology favors a coupling explanation over a pure rotation effect. The dust behavior supports this split. The repeat of a smaller pivot when a different fold crossed the lane adds weight. Null nights on either side provide the needed control. This is choreography of a modest kind, not a grand dance. It is the wind brushing a streamer in a way that physics allows and pictures record. What the verdict does not claim is as important as what it does. It does not claim that the comet initiated any activity on the star. It does not claim that the sequence of distant stellar outbursts played a role beyond setting a dramatic mood. It does not claim that space weather has any bearing on the ground beneath us. It stays inside the corridor we drew. A shock launched by the star traveled through the inner lanes. A tail that binds ions to magnetic lines felt that passage and showed it in a way that amateurs and professionals could record. There are questions that remain open by design. Could a faint timing bias exist in a restless system that makes small inputs matter at the margin? The week does not answer that. It was not built to answer that. It provides one more data point for those who will search archives for patterns across many cycles. Did the hidden interstellar visitor respond to the same weather? The week offers only hints. That part of the story belongs to instruments with different vantage points and to a calendar that stretches beyond our narrow span of nights. Still, there is satisfaction in a modest win. A testable prediction met a visible sign. A network of eyes and lenses and logs produced a record that can be checked by strangers. The known and the unknown traded places for a few minutes, and the tale became a sentence in a language that anyone can learn to read. No mystery was solved forever. No myth was born. A clean note was played on a dark stage, and it landed, where the clock said it might. The last line of the verdict is an invitation. Repeat this ritual when the next comet wakes under an active Sunday. Repeat it when the star is quiet to fill the baseline with negatives. Share methods as carefully as pictures. The work is slow, but it accumulates. In time, the ledger decides which whispers are real and which were only the sound of our own breath on a cold night. With that in mind, we step to an epilogue that holds wonder without clutching it. The sky will give us other alignments. The lesson of this one is how to meet them with patience and with joy. The week closes, and the dark feels different. You have stood under a moonless sky and watched a pale needle write in blue on black. You have learned to listen for a thin line that moves faster than a jet can turn. You have seen how a cloud thrown from the sun days earlier can arrive like a rumor and leave a mark that fades with grace. The comet now continues on its slow road away from the Sunday. The visitor behind the glare rounds its corner and begins the long glide back to the dark between stars. The star itself rolls on, building and releasing, generous with flares 1 month and parsimonious the next. Nothing in this scene owes us a finale. Still, there is a feeling that a small curtain has fallen after a clean act. The note the sky leaves is not a sentence, it is a practice. Test before tale. Keep the known beside the unknown. Invite many eyes. Accept that silence can be a result. These are not slogans. They are habits that let wonder breathe without letting it harden into belief too soon. The habits travel well. They apply to visitors from other systems and to native wanderers. They apply to weeks of spectacle and to months of quiet. They apply to every field where a pattern can seduce a mind that seeks meaning. There was beauty in the details. The way the inner coma showed ribs that came and went, like breathing. The way a disconnection slid away, as if released by the hand we cannot see. The way dust kept its slow curve while ions snapped to attention. The way a radio plot drew a diagonal thread that a camera could not see but a mind could pair with a change in light. These small matches restore your faith that the world can be both mysterious and legible at once. You do not have to choose one mood or the other. You can hold both and feel richer for it. Speculation has a place at the edge of that feeling. Perhaps a faint bias exists in a system that hovers near thresholds. Perhaps someday a survey of many seasons will reveal that comets whisper to timing in ways that are real but subtle. It remains uncertain whether this is true. It is not needed to enjoy the arc you just watched. The honest pleasures are clearer. A comet woke, a star sent weather. The tale responded. People in many places looked up and compared notes. The universe offered a small experiment, and a public accepted the invitation. If you took part, your frames and logs now belong to a larger project, one that cares about patient negatives as much as clean positives. If you only watched with your eyes, you still did the essential thing. You were present in a moment when the known and the unknown traded signals across space. That presence will color other nights. You will look at a faint green haze and see not a smudge, but a machine made of ice and dust and light. You will hear the word flare and think not of doom but of a place where magnetic lines retie themselves with a brightness that crosses the void in 8 minutes and touches instruments and then minds. In the end, the story returns to a simple image. A streamer, lit by sunlight, tied by fields, bending when a shock passes, regrowing after a cut. It is a fragile thing that speaks for a vast system. It lets you see the shape of the wind without feeling it on your skin. It turns the inner solar system into a theatre where gestures travel without sound and without touch. That theatre will open again. Different actors will take the stage. The script will rhyme without repeating. When it does, you will know what to look for and how to hold the moment in your hands without squeezing it into something it is not. For now, fold the week into memory, save the images, share the log. Step outside on some future night with no plan and no gear, and let the sky reset your scale. A distant star will flare. A wanderer will wake. A cloud will lift from the sun and go. The rest is patience and gratitude. The rest is the long work of joining wonder to proof.